Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In the lecture series, the next title is Capacitance of Parallel Plate. And before going to see about the capacitance of parallel plate analysis, we should understand the concept of capacitance. So in the diagram, there is a bounded space in between the two conducting materials M1 and M2 are placed, and considering the dielectric medium inside the boundary space where the two materials are placed having the permittivity epsilon, and the material M1 carries a positive charge Q while the material M2 carries a negative charge, and both are equal in magnitude and it is equal to Q, and there are no other charges present, and total charge of the system is 0. And in conductors, charge cannot reside within the conductor, so they resides only on the surface. So the M1 and M2 charges, the plus Q and minus Q, reside on the surfaces of M1 and the material M2 respectively. So this type of system, which has two conducting surfaces carrying equal and opposite charges separated by a dielectric, is called a capacitive system, and which gives rise to a capacitance. The electric field is normal to the conducting surface, and the electric flux is directed from M1 towards M2 in such system. So there exists a potential difference between the two surfaces of M1 and M2. Let this potential is V12. The ratio of the magnitude of the total charge on any one of the two conductors and potential difference between the two conductors is called the capacitance of the two conductor system, denoted by C. And the capacitance C is given by C is equal to Q by V12, and C is equal to Q by V. So here Q is charge in coulombs, V is potential difference in volts, and the capacitance is measured in farads, and 1 farad is given by 1 coulomb by 1 volt. And now in the capacitance, when the charge Q resides only on the surface of the conductor, it can be obtained from the Gauss law as Q is equal to surface integral d dot ds, and it is also equal to epsilon naught Er into E dot ds. We know that displacement density vector d is equal to epsilon naught E, and it is also represented as integral over the surface area epsilon E dot ds. Now the V is the work done in moving unit positive charge from the negative to the positive surface, and can be obtained as V is equal to integral of minus E dot dl. So this is line integral, or it is equal to minus of integral E dot dl vector. So the capacitance can be expressed as C is equal to Q by V. Now Q is substituted, that is integral over the surface area epsilon E dot ds divided by the V is minus integral of E dot dl. So now the capacitance in parallel. So capacitance in parallel, we can directly add all the capacitance value in order to get the equivalent total capacitance, that is C equivalent is equal to summation J is equal to 1 to N Cj. And when the capacitance are connected in series, the formula is given by 1 by C equivalence is equal to summation J is equal to 1 to N 1 by Cj. So this is the formula of getting total capacitance when the capacitors are connected in series. And now in the capacitors are connected in series, V1 can be given as Q by C1, V2 is Q by C2, and V3 is Q by C3. So here in the diagram there are three capacitors are connected. So the total charge V by Q is equal to 1 by C equivalent. We have V by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. So for all the capacitors in series, the charge on all of them is always same, but the voltage across them are different. So this is the example capacitor circuit. So here C1, C2 are parallel, and these two are parallel and in series with C3. So for finding the total capacitance C123, it is given by C12 C3 by C12 plus C3. So suppose if C1 is 12 microfarads, C2 is 5.3 microfarads, C3 is 4.5 microfarads. We can calculate by using this formula, we get 3.57 microfarads. So now the capacitance of parallel plates. Consider the diagram. There are two parallel plates which are having the area A, and the voltage across is V, and the distance of separation between the parallel plate is D. So here the line of integration is taken here, and now to find out the total capacitance for this parallel plate, considering the electric field is constant and the geometry is very simple for this case, only the area and plate separation is only important. So to calculate the capacitance, we first need to determine the electric field between the plates. So we use Gauss law with one end of our Gaussian surface closed inside one plate and the other closed in the region between the plates, while neglecting the fringing at the ends. So this is given by E naught epsilon naught E dot ds equal to Q, and for finding potential difference, this V is given by V1 minus V2, it is given by minus of integral E dot ds. So by substituting the Q value and the voltage value, we get the capacitance C is equal to Q by V, and this V is ED because E is constant here. So substituting, we get the final answer for the capacitance for parallel plate C is equal to epsilon naught A by D. So now the assessment questions. What is meant by capacitance? How to calculate the capacitance if the capacitance are series? We know that for capacitance in series, we get 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3, etc. And potential difference between the parallel plates we can get easily from the formula of potential difference V is equal to integral of E dot dl. And the capacitance of parallel plate capacitor, we just now arrived, it is C is equal to epsilon naught A by D. So thank you.